All right. Today we're looking at Chapter 5, Topic 4, which is dividing polynomials using synthetic division. Synthetic division is a little bit different than long division. It's faster than long division. It's easier than long division as well. So, however, this synthetic division method only works if the divisor is linear. Okay, so the divisor has to be in the form of x plus a number or x minus a number. Okay, so we can't be dividing by x squareds or x cubes. It has to be x plus number, x minus number. Now I'm going to show you all these steps. You can pause this and look at these steps and write them down and read them, but I'm going to go through them as I do a problem. Alright, so our basic setup here for this type of division is going to be, we're going to start with an upside down division symbol. So like this. Alright, upside down division symbol. There's two things that we need to determine to fill this out. We need to determine the zero of this polynomial, and we need to determine the coefficients of this polynomial. So this is the dividend, this is divisors, or the divisor. So the dividend has coefficients 1, 2, -6, and -9. Okay, so we put those right here. 1, 2, -6, -9. Alright, leave some space underneath. We're going to need that space underneath. Alright, now we need one other thing, and that other thing is going to come from what we're dividing by, which is x minus 2. Okay, the problem is x cubed plus 2x squared minus 6x minus 9 divided by x minus 2. Alright, so the number that we're going to use is going to be the zero of this. If this were a factor, what the zero would be, it would be 2. It's the zero for this if this were a factor. So it'd be positive 2, because 2 minus 2 is 0. Alright, so it's essentially always going to be the opposite of the number that you see here. X minus 2, we're using the number 2. And what are we using that for? We're going to put it on the outside over here. Alright, it's on the outside of the blue division symbol. Alright, this is now set up. We haven't started yet, but this is how we want it to set up. We got the 0 on the outside, we got all the coefficients on the inside, and now we can start the process. Step 1 of the process is to bring the first number down. Okay, it always comes down. So this is a 1, so we're going to bring down a 1. We never do anything to the first coefficient, it just comes straight down. Now we can start the process, and this is a repetitive process. We do the same thing at every column. We multiply these two together, the orange and the pink. So 2 times 1 is 2, and that number goes here. 2 times 1 is 2. And that number goes here. Alright, now that we have these two numbers in this column, we're going to add them together. 2 plus 2 is 4. And then we repeat the process over again. Alright, we've got a new number here, 4. We multiply it by 2. 2 and 4 make 8, and 8 goes right here. And then we repeat the process again. We add them together, -6 and 8, which is 2. Once again, we multiply 2 and 2, which is 4. So 4 goes right here. And then we add these two together, -9 and 4, which is -5. Alright, so the numbers that we get are 1, 4, 2, and -5. So what does this tell me? It actually tells me the coefficients of the divisor, or sorry, of the quotient. This is what this will tell me. It's the coefficients of the quotient. The one on the very right, if we start from right to left, they always go in the same order. This would be the remainder. This would be the constant. This would be the x. And this would be the x squared. All right, it always goes in that order from right to left. Or you can also look at it from left to right as being 1 degree lower than the coefficient that we started with. This was x cubed, so this is x squared. This was x squared, so this is x. This was the coefficient of x, so this is the constant. And this was the constant, so this is the remainder. But I prefer to look at it from right to left. It always goes from right to left, remainder, constant, x, x squared, x cubed, x to the fourth, etc. All right, from right to left, it always goes in that manner. All right, well, what that tells us is that if we do the division, x cubed plus 2x squared minus 6x minus 9 divided by x minus 2, that was the original problem. If we do this division, what we get is 1x squared, or just x squared, plus 4x plus 2, the constant is 2, and then the remainder is negative 5, and remember the remainder always goes over the divisor. So the remainder of 5, or negative 5, I'll put a minus sign here, goes over the divisor, which was x minus 2. So this would be the quotient when we divide these two polynomials. X cubed plus 2x minus 6x minus 9 divided by x minus 2 is equal to, this is the quotient, x squared plus 4x plus 2 minus 5 over x minus 2. That's the remainder. All right, so we were only allowed to do this because our divisor was in the proper form. Okay, it has to be x plus k or x minus k, and this was x minus k. So we were allowed to use synthetic division. If it were not like that, we would have to use long division. All right, once you understand what's going on here, this is actually relatively quick. We set it up, so we got the division symbol. Our coefficients are 3. Okay, look, it goes from x to the fourth to x squared. So there is an x cubed here. It's a 0x cubed. So 0, so it's 3, 0, negative 15, 32, and 1. Okay, you have to account for any of them that are missing. So if there's an x to the fourth and an x squared, there should be an x cubed in between, and it should have a coefficient of 0. So my coefficients are 3, 0, negative 15, 32, and 1. And we see that, yes, my divisor is in the proper form, and the 0 is negative 3. Okay, it's the opposite of this 3. So negative 3 is going to go here. And then we start the process. This one always comes straight down. Okay, the 3 just comes straight down. We multiply them. Negative 3 times 3 is negative 9. And then we add these in the column. 0 plus negative 9, which is negative 9. We multiply again. Negative 3 and negative 9 is 27. And then we add them in the column. Okay, negative 15 plus 27 is 12. And then we multiply them again. Negative 3 and 12 is negative 36. And then we add them. 32 plus negative 36 is -4. We multiply it again. -3 and -4 is 12. And then we add them. 1 plus 12 is 13. Alright, so these numbers represents the coefficients. This is the remainder. This is the constant. This is the x. This is the x squared. And this is the x cubed. Alright, from right to left, it always goes in that order. So we can say that when we divide 3x to the fourth minus 15x squared plus 32x plus 1 divided by x plus 3, what we get is 3x cubed minus 9x squared plus 12x minus 4, and then we have a remainder, and that is 13, and that's going to go over our divisor, x plus 3. So this would be our quotient. When we divide these two polynomials, this is our quotient. How do we know it's division? There's a division symbol right in between. This divided by this. Alright, so this is our quotient. Alright, so number 3, x cubed plus 2 divided by x minus 1. We can set up the synthetic division because the divisor is in the correct form. We notice that we're missing a lot of coefficients here, okay, because it goes straight from x cubed to the constant. So what we should be looking at here is 1x cubed plus 0x squared plus 0x plus 2. Okay, so my coefficients are 1, 0, 0, 2. So 1, 0, 0, 2. And my 0, x minus 1, my 0 would be positive 1 or just 1. So 1 over here. Alright, this one always comes down. Then we multiply. 1 times 1 is 1. Add these two together. 0 plus 1 is 1. Multiply again. 1 times 1 is 1. Add these two together. 0 and 1 is 1. Multiply again. 1 times 1 is 1. Add these two together and we get 3. Alright, so these are the coefficients. In order from right to left, my remainder, my constant, my x, and my x squared. So x cubed plus 2 divided by x minus 1 is equal to 1x squared, or x squared, plus 1x, or plus x, plus 1, and then my remainder is 3, and the remainder always goes over the divisor, so over x minus 1. And this would be my quotient. Alright, so the homework is on 5.2, page 63, numbers 9 through 11, and number 14, page 64, number 13 through 16.